Welcome to
Nay.
Do it.
Channel Everyone. This is episode 2026-0406. Okay, so today we are diving into a new paper that tackles a really tough problem. Jiyoung, help me out here. We all know that giving an AI agent a goal and letting it learn through trial and error, reinforcement learning, is powerful. But what happens when the task is long and complex, like having a conversation or controlling a robot?
That's exactly the core challenge, Isabel. In these multi-turn agentic tasks, the AI makes a sequence of decisions. The problem is, the feedback from the environment can be delayed and very noisy. A single small mistake early on can send the agent down a wrong path, and the noisy feedback makes it harder and harder to recover. It gets lost in its own chain of errors.
Right, it's a vicious cycle. The model takes a suboptimal action, gets confusing or misleading observations back, and then uses that bad context to make its next, even worse decision. Standard exploration, just trying random things, often just digs the hole deeper because it's so susceptible to this randomness. The agent's own reasoning process becomes part of the problem.
So it's like, if I make a wrong turn driving because of a confusing sign, and then my GPS starts giving me instructions based on that wrong location, I'm just going to get more and more lost. Trying random streets might not help. I need to stop and reassess.
That's a perfect analogy, Isabel. The paper we're discussing proposes a method called ProCeedRL. It stands for Process Critic with Exploratory Demonstration Reinforcement Learning. The key innovation is shifting from passive exploration to active intervention.
Instead of just letting the agent wander and hope it finds a good path, ProCeedRL introduces a process-level critic. Think of it as a supervisor watching over the agent's shoulder in real time. It monitors the entire interaction, not just the final outcome.
Exactly. And when this critic sees the agent starting to go down a bad path, accumulating errors, it can intervene. It provides what they call reflection-based demonstrations. These are corrective actions or guidance that show the agent how to stop the error chain, how to get back on track.
So it's like my driving analogy again. The process critic is the friend in the passenger seat who says, "Whoa, Isabel, I think we're lost. Let's pull over, look at the map together, and then take this specific turn to get back to the main road." It's an active demonstration to break the cycle.
Precisely, the agent learns from these guided interventions, these exploratory demonstrations, as well as from its own on-policy trials. This dual learning source significantly boosts exploration efficiency. The paper shows it works well on very complex tasks, like deep search problems and embodied AI tasks where the agent controls a body in a simulation.
The results are compelling. This approach breaks through the performance ceiling that standard methods hit. By learning how to explore better and how to recover from mistakes, the agent achieves much stronger final performance. It's a more robust way to train AI for the messy, long-horizon tasks we want them to do in the real world.
That is fascinating. It moves the training from just what to do to also how to think about what you're doing when things go wrong. A meta skill for recovery. Thank you both, JJ and Jiyoung, for that deep dive.
Thank you, Isabel.
Thanks.
And thank you for watching. We'll see you next time.